Hey guys, hi, what's up? Yo? Okay, so I believe all of you guys are doing good. Good evening and welcome to the masterclass where we always learn something interesting and amazing and innovative, creative, and all those stuff. Correct. So, guys, good evening and welcome to the master session. I hope all of you guys are doing good. Hey guys, what's up? Sorry for making you wait for so long. We're just waiting for all the students to come up. That's what we were all doing. So I believe all of you guys are doing good. Had an amazing day. Let's make it completely more amazing by understanding some crazy concepts today. Shall we? Okay. Now before starting this session, for those students who don't know me, let me just introduce myself. My name is Abhishek. I'm a master teacher for physics at Vedantu. I'm also an aerospace engineer. That also defines that why am I teaching physics, because I love physics. I love space science, astronomy, astrophysics, and a lot of stuff. So I believe a lot of you guys would also be interested in that. Okay. Now, what is this session about? What is this master session about? As you already know, that the topic itself speaks it out, that we are going to understand in depth working of an AC generator. Now for those students who face difficulty in this particular part, that's why it is there, and you know that many of you guys have requested me to take this topic up after my DC motor part. That's why I'm doing this. And also, if you have not watched my previous webinars related to DC motor or other parts of magnetic effects, please go and watch. You will understand a lot of stuff. I believe you will understand a lot of stuff. And if you face any difficulty in any of the videos, put down in the comments. We'll do that. Not a problem. Okay. So today, specifically, let's focus our energy on the concept how to score 100% of marks in magnetic effects of electric current, specifically on the working of AC generator. Okay. And also, by the way, I'm the inventor of Rocket Pro. Many of you guys have been a part of this, and many of you guys have showed interest also in this. And we'll be launching Rocket Pro again in the month of October. And people who don't know it, it's nothing but a rocket science course where we not only learn the technical aspects, but also we build rockets by our own hands and launch them. Okay, not only rockets, aircrafts, and all those stuff. So that's about me. Not that important. Let's jump onto the concept for today. Okay, without spending any more time on this. Now, as I said, let's focus our energy and let's try to start this session with a very good quote. Okay. Now, this quote specifically said by Mr. Henry Ford. I believe all of you guys know who is Henry Ford, the proud inventor of the Ford company, the establisher, founder, and everything. Correct. So he said one day, when everything seems to be going against you, remember that airplane takes off against the wind, not with it. Correct? Does that make sense? So now, since you are in your 10th standard, and many of you guys could be in the 9th or might be going to 11th, 12th, and all those stuff, you might be facing a lot of resistance in your life. Correct? Lot of problems, everything, peer pressure, parent pressure, focusing on you to score marks, but chill. Take a relax. Everyone has its own speed. So go with your own pace, you will be successful. Trust me on that. Great. So keeping that in our mind, being motivated, let's move on to the topic. So what are we going to learn today? We will learn some crazy CBSE 10 concepts. Starting right from electromagnetic induction, as you can see in front of you. Then we'll jump on to the Flemings right-hand rule. Cool. And we will study these two topics only to understand what is electric generator. That is what's the topic states, AC generator. Correct. So why do we need we need to learn electromagnetic induction first, then right hand rule, then we'll jump on to AC generator to understand it completely. Okay. Uske baad, one of the hot favorite questions of CBSE 10th board, that what is the difference between electric motor and electric generator? We will try to pitch in that as well. So by the way, all these topics here are actually 2 to 3 marks, 5 marks questions also in CBSE 10. For example, electromagnetic induction comes for 2 marks, and with diagram it comes for 3 marks. Fleming's right hand rule also comes for 2 marks. Electric generator with construction, working principle, and all those comes for 5 marks. Difference between again comes for 2 to 3 marks. So individually these topics are important. Also as a whole, for this chapter, this is super crazy topic. Okay, it's very interesting also. So So let's try to make it way more interesting. And on the way, obviously, I'll be giving you some crazy best approaches how to understand it very clearly. ठीक है? चलो फिर आगे बढ़ते हैं without spending any more time. So starting right from the prerequisite concepts, that is, to understand this particular topics which you are going to learn today, you must know certain stuff. I'm pretty sure all of you guys would have completed your midterm examinations or are going to write it. And for many of you, electricity and magnetic effects would be the chapters, correct? So I believe you know this concept. Even if you don't know, let's do a quick revision of it. So the first prerequisite concept which you know should be Oersted's experiment. Now one day, as a revision, let me take this up. So one day Mr. Oersted was working on his lab and he was doing some experiments with his conductor and circuits and all. And on the other side of the table, there was a compass. Correct, you know the story. So what happened? As soon as he turned on the electrical switch of the circuit, electric current started flowing through the circuit. And suddenly he saw that the compass sitting at the other end of the table deflected. And everyone was shocked because it's electric field here, that's a compass. How can that get deflected? He then again and again did this experiment and he found out. What did he find out, guys? I can see many of you guys thinking and many of you guys putting the answers in the YouTube chat. Very good. He found out very clearly that whenever electric field is generated or electric current flows through a conductor, a magnetic field is also generated. Remember this, store in your mind. Okay? It's very important to know. Whenever there is an electric current flowing through a conductor, a magnetic field is also generated. And that magnetic effect, that magnetic field hindered with the compass, due to which the compass started moving. Okay? So it is like, electric field and magnetic field are like bhai. They are like bros. So this is same as Ohm's law. If you remember Ohm's law stated V is proportional to I. Correct? All of you remember what does Ohm's law state? V is proportional to I. Can you tell me, can current exist without voltage? Put it in the chat. Can current exist without potential difference? Can current flow without potential difference? Yes or no? What would be your answer? Very nice. Awesomely correct, guys. Exactly correct. It cannot happen. Similarly, if potential difference is there in a circuit, can there be any chance that current will not flow? Can there be any chance? Nope. So same as how potential difference and current is bye or bro. Similarly, electric field and magnetic field are also bye-byes. If electric field is there, magnetic field is there. Magnetic field is there, electric field is there. Okay, so that's what proved by Oersted. And he gave at the end 4 conclusions. I want you guys to remember these 4 conclusions. Very important for your individual question from Oersted experiment in your CBSE 10 board also. Number 1, starting right from, he said very clearly, if electric field is there, magnetic field is there. Number 1 statement. Number 2 is, if we increase the value of electric current in a circuit, यानी कि we increase it from 5 amperes to 10 amperes, the magnetic field also increases. That's what he found out. Okay? Similarly, if we reduce down the electric current, magnetic field also reduces down. So they are like proper bye-bye. Completely. Like so close relationship. If this is high, this is also high. If this is low, this is also low. Okay? Then he also found out, if I change the direction of the current in a circuit, magnetic field's direction also changes. 4 things which you need to remember from Oersted experiment. Cool? Happy? Okay. Next thing, we have been talking a lot about magnetic field. What is this magnetic field? It's very simple to understand because itna simple concept hai ki like it just goes into a brain. Magnetic field is like, for example, if I keep a magnet here, imagine if I'm keeping a magnet here, and if I keep one iron piece here at first position, and if I keep one more iron piece here, this is second position. You guys think and tell me which one of the iron pieces will be attracted to the magnet more effectively, more strongly. I'm pretty sure you guys are brilliant enough to know this. Awesomely correct. Very good, guys. Come on, think about it. Think about it. Yes, I'm getting few answers. Very good. Awesomely correct. Exactly correct. It would be definitely the first one for obvious reasons because it's close to the magnet. Correct. So magnetic field is magnet is more stronger nearby, but far away it is not that stronger. That means there exists a region. If I take this pen here, imagining that is a magnet. Near this magnet there exists a region within which the magnetic field produced by this magnet is super strong. But beyond this magnetic field, the magnetic strength, magnetic force of the magnet is not that strong. It's just like chulubulu, nothing. Take it. So that is magnetic field. I can give you a very single 1 mark definition for this particular part. Magnetic field is the region in which the magnet's magnetism can be felt. The magnet's magnetic force can be felt. Simple. Cool? So magnetic field समझ में आ गया. But this magnetic field is really naughty. Why is it naughty? Because we cannot see it. It's very precious. It's like Mr. India. It's completely invisible. So we cannot see magnetic field. So one day if I come and tell you, show me magnetic field, what will we do? We cannot do anything. Correct? That's when the concept of magnetic field lines came. Correct? Exactly correct. So that's when the concept of magnetic field lines came. Now what is this magnetic field lines? If you need to represent magnetic field which is invisible onto a piece of paper or on the screen as you see right now, we need to use something called as magnetic field lines. तो हम क्या करेंगे? If I draw a magnet here, as you can see here, I drew a magnet. Surrounding this, I will draw the magnetic field. Cool. So that will be nothing. So what I have drawn here, that is nothing but the magnetic field lines representing magnetic field. बात खत्म. इतना ही है. So one line definition for magnetic field lines for easy understanding. Magnetic field lines represent magnetic field and its direction. बात खत्म. Simple. Cool. Now this magnetic field lines have a lot of properties, very important properties which also come near CBSE 10 board examination, but I will not be taking that here because I've already taken that in my previous webinar, previous master session. So if you have not known about it, you can go and check that out video, but right now focus, because for this particular session magnetic field lines properties जरूरत नहीं है, are not required. ठीक है? तो if you want to know about it, you can check out the other video, but right now focus. So these are the prerequisite concepts which you need to know to understand electric generator. Oersted experiment, magnetic field क्या होता है, and magnetic field lines. Cool, awesome. Give me a quick guess if all of you guys are following me till now. Give me a quick guess. If all of you know this, if all of you understood this, give me a quick guess right now on the chats. Awesome, very good. I can see few no's also. Ooh, very nice. Concentrate, guys, concentrate. Okay, anyways, guys, so we have understood this part. Let's jump on to the major concept. I want all of you guys to identify this person right here. So guys, we are moving into electromagnetic induction, the first topic for today. So guys, who's that guy there? That guy who destroyed your life. Because of him, you're studying electromagnetic induction. The founder, the discoverer, the inventor of electromagnetic induction. Who's that? Oh, I'll give you 20 seconds to answer that. Let me see how many of you guys know what you're studying. Interesting. Acha. Good. Okay, many of you guys still thinking? If you're able to identify or not. Sir, that he looks like Albert Einstein, sir. No, right? Definitely. Very good. Many of you guys were able to answer that. He is no one else but Mr. Michael Faraday. I'm hoping I'm writing the spelling right. I'm not sure. But he is no one else but Michael Faraday, who actually discovered the concept of electromagnetic induction. Now, I would not say he discovered something. I would say he followed Oersted. He followed Oersted's experiment. He continued Oersted experiment. Because I want you to remember now what did Oersted said. He said very clearly, whenever there is electric field, magnetic field is present. What did Faraday do? Faraday reversed this scenario. Faraday said, if one way is happening, then the return journey must also be happening. It must be a two-way trip. What I'm trying to say here is that Faraday said, if an electric field can generate a magnetic field, then it must be there that a magnetic field can in turn generate an electric field. ऐसा उल्टा होना चाहिए, because they are bhai-bhais, they are bros, correct? So it must happen. Got my point? So that's what was done by Mr. Michael Faraday. He said very clearly that whenever I have a change in magnetic field, please note down the word change. Please note it down. It's not only any magnetic field, it is the change in magnetic field. I will tell you what is the reason here, why are we using the word change later, but right now focus here and understand it is not just magnetic field, but it is the change in magnetic field if exists near a coil, then that coil will have electric current passing through it. Just for example here, as you can see in front of you, I have two objects. I have the first object here, which is nothing but a conductor, and the conductor is coiled by wire, and that wire is connected with a galvanometer. You can see that there is no battery in the coil, there is nothing. And number two object, as you can see in front of you here, is a magnet. Now what are we doing? We are moving the magnet left and right, left and right. Why? Because if we keep it at a place, it is magnetic field, just magnetic field. But if we start moving it, it's pretty obvious. If I move the magnetic field also will start shifting. Correct na? If my magnet is here, magnetic field cannot be at infinity or somewhere else. Correct? 2 kilometers apart, it cannot be. If a magnet is here, magnetic field will be here. If a magnet is here, magnetic field will be here. As simple as that. Correct? So when my magnet is moving with respect to the coil, the magnetic field is also changing. This change in magnetic field with respect to the coil induces a current in the circuit. Now as you noticed, I use the word induce. Induce means kuch dalna, to start something. So this magnetic field here started producing electric current in that particular circuit, and that we can notice in the galvanometer very clearly. As you can see that the galvanometer is deflecting towards left, towards right. What does that indicate? That indicates that current is being generated whenever the magnet is moving. But the magnet is stationary, no current generated. Okay? But this is not electromagnetic induction. I'll tell you what is electromagnetic induction. This is not it. This is the basics. अभी हम एक step करके आगे बढ़ेंगे. Cool. Now, this was the founding of Michael Faraday. That whenever there is a change in magnetic field, electric current is induced in a coil. Now if you remember, let me recap what did Oersted said again with this help of this particular GIF here. Whenever there is an electric circuit with a current passing through it, then there must be a magnetic field. That's what Oersted said. ठीक है? So यानी कि अगर यहाँ पे there is one circuit with a battery and the current is being produced with the help of the battery, now current is moving continuously, there must be a magnetic field being generated. As simple as that. तो अब हम क्या करेंगे? A very interesting thing we'll do. What did Faraday did? He took out this magnet from the scenario. Instead of this magnet, he kept this particular coil here. This coil he took and kept it here. Look at that. Because what does a magnet do? A magnet produces magnetic field. यहाँ पे this first coil here is also producing magnetic field due to the current passing through it. So more or less this is also a magnet. This and all he thought. ठीक है? So he removed the magnet, he kept that coil there. ठीक है? He kept that coil with the battery, with the source, and this coil he called it as primary coil. This coil he called it as primary coil. Got a point? Or a primary conductor or the primary circuit which is producing the magnetic field. Now he thought if a magnet can produce a current there, then this magnetic field must also produce a current here. That's what he thought. Correct? And he actually found it out, and that was completely correct. How did he do it? Next to the primary coil, he kept one more coil called as the secondary coil without a battery, anything. He just attached it with a galvanometer, which you see in front of you, just to measure whether current is being produced or not. And according to his surprise and according to his thesis and theory, he was damn correct. Due to the flow of electric current, the magnetic field in the primary coil was generated, and hence it was acting like a magnet. And this magnetic field here produced by the coil A or primary coil induced a current in the second coil, same to same as how magnet would have done it. Got my point? I'm going to repeat this again, guys. One very simple thing. Now what I'm talking is now electromagnetic induction. What is electromagnetic induction? Whenever there are two coils kept together, one being a primary coil, one being a secondary coil. The primary coil is actually connected to a battery. This battery now produces a current through the primary coil. And due to this current, a magnetic field is generated. Now when this magnetic field is generated, this magnetic field induces a current in the secondary coil kept next to the first coil. This process is called as electromagnetic induction. Talia. That's it. That is your electromagnetic induction right there. I hope all of you guys understood this. Now, about 25% of you might be getting a doubt here. Sir, in the case of this particular part, you said change in magnetic field. Correct? Change in magnetic field you said, sir, but here the coil is not moving. So it must not be changing. The magnetic field is not changing then. And you guys are damn correct. Very nicely correct. Very good. If you're thinking about this, now quickly tell me how many of you guys were thinking about it. How many of you guys? कि सर यहाँ पे तो magnetic field change नहीं हो रहा है. So if a magnetic field is not changing, the current must not be generated there. Many of you guys must be thinking. If you're not thinking, start thinking. Curiosity ऐसे ही बढ़ती है बेटा, वरना नहीं बढ़ती. Okay, great job. If you're thinking it, good, awesome. I can see many of you guys answering me. Great job, guys, awesome. So cool. Then comes the concept of AC. सब यही सोच रहे होंगे ना भी कि सर we are going to study AC generator, DC motor तो we have already studied. What is this AC and what is this DC? Guys, can you tell me what is the full form of DC and AC? Let's start with DC. Tell me guys quickly, what is the full form of DC? बताइए जल्दी. Let me see who is going to answer me well. Great job, exactly correct. अरे 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 क्या बात है. Okay, I can see that many of you guys know that the full form or the expansion of DC is nothing but direct current. And the expansion of AC, good job, exactly, it is called as alternating current. Correct, direct current or alternating current. इन दोनों के बीच में difference क्या है? What is the basic difference between this direct current or alternating current? It's pretty simple. इतना समझ लो बस. You guys are going to rock in 10th standard. Just understand this very clearly. You guys all are going to be rock stars. Trust me on that. Simple. Let me start with alternating current. Alternating, what does that mean? According to English, alternating means which changes, which alternates each and every second or with distance. Correct, it changes. So alternating current का अगर मैं ग्राफ बनाऊंगा, if I make a graph for alternating current where y-axis is the current and the x-axis is the time. Cool. Where y-axis is the current and x-axis is the time. If I make a graph, ki how is my current going to look like after every second, we will notice that this current is going to give me a sine curve. I believe all of you guys know what is a sinusoidal curve or a sine curve because you must be studying your trigonometry in 10th standard. This kind of a graph is called as a sine curve or sinusoidal graph or sinusoidal curve. Okay? So it is like a wave. What does that mean? That means current at each and every second is changing. First second, this much. Second, 0. Third second, this much. Fourth second, again 0. That is an alternating current. A current which changes with time is called as alternating current. Clear? Awesome. Very good. Now what will be direct current? Chalo, let me think and tell me, how will a direct current look like in the same graph? Let me make the y-axis as current and let me make the x-axis as time. Think and tell me, how will the direct current look like? Just think. I'll give you 10 seconds to think about it. But सोच के बाद, if you can identify that after understanding alternating current, you guys are rock stars. Trust me on that. Okay, you have 5 more seconds, guys. How is the direct current going to look like in the graph? Think and tell. Awesome, very good. So I can see many of you guys were thinking and a lot of answers came up. Okay, very good. So basically, direct current is that kind of a current which do not change with time. Simple. So for direct current, it will look like a straight line. As say, simple. Excuse me. So yeah, what is a direct current? It does not change with time at all. 1 second also this much. Second also this much. Third second also this much. Okay. So I believe all of you guys are pretty clear about this, and whatever I've told you is a 12th standard concept. These graphs come in 12th standard. Okay. So as I said, I'll repeat again. What is direct current? A current which does not change with time. Alternating current, a current which changes with time. Okay. Now the reason why I've told you this is pretty important. Understand. We were discussing, sir, here the magnetic field is not changing. It is a constant. It is kept at one position. Here the magnetic field is not changing. So how can it produce a induced current here in the secondary coil? This was our primary question. To understand that only, I taught you about alternating current. Here, this particular battery, let me not call this a battery because a battery provides a DC current. Let me connect this up to a power source. Which power source? The main power plug which you have in your houses. That power plug or the source. That is the source here. And all of you guys must know that to your houses, DC do not come, AC comes. I believe you know. For all the houses and shops and everywhere, alternating current comes into your houses. Correct? 1 second. So think about it. Let me know. I needed that. Thank you for waiting. Yeah. So yes. So I can see very clearly that वहाँ पे AC जा रहा है. ठीक है? Now, and we proved with respect to time, alternating current changes. We proved. So if current is changing, guys, think very carefully. In the primary coil, the magnetic field produced by that current should change. किसने बोला था? This was told by Oersted very clearly. If I change the value of current, magnetic field will change. Correct? This we already studied. So you cannot say no. Correct? So when alternating current changes with respect to time, magnetic field also changes with respect to time. So the statement which we said that magnetic field is constant here, no, it is not constant. It is changing. It is definitely changing. So now due to this change in magnetic field, induced current is generated in the secondary coil. Bas, काम खत्म, इतना ही है. So that was electromagnetic induction for all of you guys. I would repeat the definition of electromagnetic induction once again for all of you. Electromagnetic induction is a phenomena, okay, where a primary coil connected with a source of current produces an alternating current due to which an alternating magnetic field is generated. And this alternating magnetic field induces a current in the secondary coil kept next to it. That is nothing but electromagnetic induction. बात खत्म. Founder was Michael Faraday. ठीक है. अब ये बात आती है. Now if I hope all of you guys understood that. Give me a quick yes if all of you guys are following me till here. Give me a quick yes कि मतलब यहाँ तक electromagnetic induction is like crystal clear in everyone's mind. Tell me quickly. Great job. Awesome guys. Very good. Thank you. Thanks a lot. अभी चलो आगे बढ़ते हैं फिर. अगर सबको मजा आ रहा है तो आगे बढ़ते हैं. Now let's try to understand a very important question that comes in your board examination. Due to electromagnetic induction, induced current got generated. Tell me what is the direction of the induced current? One of the most famous things. What is the direction of induced current? Magnetic field. So as you guys know, I'm moving towards now the Fleming's right hand rule. Correct. Fleming's right hand rule tells us what is the direction of induced current. For many of you guys, this might be a bit confusing. Because For the case of DC motor and everything else, we use Fleming's left-hand rule. Now, since Fleming had two hands, he used both of the hands to give some or the other rules. Now, I'm pretty sure when you go to your engineering and all, he'll be using his two legs also, giving you Fleming's left leg rule and right leg rule as well. I'm pretty sure. Okay, let's hope that does not happen. But anyways, coming back to the point. In the case of electric generator, we'll be using Fleming's right hand rule. Okay. Now, in terms of theory, both of them are same. Let me recap a bit ki what was Fleming's left hand rule. Okay. It stated very clearly कि whenever I have current carrying conductor placed in a magnetic field. So for example, if I have a conductor like this placed in a magnetic field, so current is flowing in this direction. I will extend out my left hand and I'll project my forefinger in the direction of the magnetic field. I will project my middle finger in the direction of the current, as you can notice. Then the thumb will give me the direction of the force being applied on the conductor by the magnetic and the electric field. Got my point? I'll repeat this again. Whenever there is a conductor carrying current placed in a magnetic field, it experiences a force. Correct? You know that whenever current carrying conductor is placed in a magnetic field, it experiences a force. It's very simple. You know that very clearly. Correct? So how will you give the direction of the force? That will give you the direction of the force by using Fleming's left hand rule, where it states that if you project out your first finger, your forefinger, it will be the direction of the magnetic field. If you project out your middle finger, this will give you the direction of the current. Then your thumb will give the direction of the force being applied on it. As simple as that. ठीक है? तो ये हो गया आपका magnetic field. This becomes your current. Then this will give you a force. Same thing is right hand rule also. Same to same. There is no difference. Same to same. There is no difference at all. But point ये है. The point here is, in the case of Fleming's left hand rule, we are actually finding out the direction of the force. That is the ultimate point. But in the case of Fleming's right hand rule, what are we trying to find out? The direction of force? No. The direction of magnetic field? No. But the direction of the induced current. That is the only difference. Hence we need to change our hands. ठीक है? तो अभी मैंने ले लिया right hand. Same thing, same stuff. बस इतना है कि current thing which we need to say it at the last. So he said, if I have a current carrying conductor placed in a magnetic field, then imagine that the object is moving, the conductor is moving in the direction of the thumb. If the object, imagine if I have a coil here or a magnet here, the object is moving upward. So if I kept that the object is moving in the upward direction, that is the thumb, and if the middle finger or the second finger moves in the, or it's representing the direction of the magnetic field, then your forefinger will give your direction of the induced current. That's what was said by Mr. Fleming in the right hand rule. Simple scenario. समझ में आया? I'll repeat it once again for everyone. One final time. Fleming's right hand rule states that if I have my thumb in the direction of the force or the movement of the object, then, and the second finger represents me the direction of the magnetic field, then the forefinger will give me the direction of the induced current. As simple as that. That's what's said by Mr. Fleming's right hand rule. So I believe all of you guys understood that very clearly. Correct? So now if you can notice, now we have done electromagnetic induction, we have done Fleming's right hand rule. अब हमें आगे बढ़ना है next topic में, as you guys know, which is nothing but the topic which we have been studying till now. For which we have been studying till now, that is electric or AC generator. ठीक है? Before going on to this, let's take a small break of 1 minute. Let's take a small break of 1 minute. In this, let me give you a question. Tell me the answer of this question in the comments below after the session. not now. Let's take a small break of 1 minute so that your brain is fresh, have some water, not a problem. You have been watching the video. So basically just think, okay, I'll give you a question. Just tell me what is the answer in the comments below after this session. Okay. So imagine guys that you have a coil here. And this is all the CBSE 10 question, okay? So just think about it. So coil here is related to the topics which I covered right now. And it's wounded up by copper wire, conductor, and then you have galvanometer here connected to it. Okay, simple scenario, galvanometer hai, sab baat khatam. Next to it, I am bringing you a magnet. North pole, south pole. Okay, North pole, south pole, magnet. Now just tell me two things in the comments below after this session. When the North pole goes near it, what is the direction of current? When the North pole goes away from it, what is the direction of current? So I would require what is the direction of I1 and I2. Okay. When the North pole goes near to the magnet, near to the coil, what is the current direction produced? I1. And when it is away from it, what is the current direction produced? I2. This you take it as a homework and tell me the answer in the comments below. As I already told you, can do that. Okay. Also, you can send me the homework on this email ID k.abhishek@vedantu.com. You can use this also to send me the homework, but I would prefer that you guys put it in the comments below so that we can all see कि बाकी बच्चे भी क्या answer दे रहे हैं. Correct. So that was your homework, guys, and that is the email ID. If you want me to do something, let me know about it on the email. Great, guys. Awesomely well done. Now I believe all of you guys are focused now completely. Everyone remembers what and all we studied till now. So let's jump on to the final concept today. Completely energetic. We are going to understand the concept of electric and AC generator. Now, for people who have not seen an AC generator, it looks like this. In real life, this is the AC generator. Okay? Now, I don't know how many of you guys have it in your home, but I don't have it and have seen it in many of the shops, and much bigger size than this and much smaller size than this and plenty of the stuff. Okay? And this is how, and this is what it looks like internally. Matlab, if you open this all up, you will ultimately find this 4 to 5 basic structure present inside any kind of an AC generator. So now our problem in which CBSE 10th asks us is this basic stuff. Tell us what is the basic working of this kind of an AC generator. That's what they ask us in CBSE 10th. So basically, if I just boil it down to what do they ask basically are these three things. Okay. First, they will ask you what is the working principle of an AC generator. For DC motor also the same. This particular part is very same for DC motor and AC generator. So, दोनों के लिए बोल रहा हूँ. I'm telling for both of the stuff now. So, for both of the cases, they will ask you what is the working principle, what is the construction, and what are the functions of each and everything. And then once you know all of them, you just can correlate all of them and tell us how does it work. Simple scenario. Okay. So, working principle, construction, and function. Now, let's go part by part. Let's understand what is the working principle. Okay. Let me just recap a bit what was the working principle of DC motor. In the case of a DC, because it's exactly opposite. Isliye I want to create that clear difference between DC motor and electric generator, AC generator in all of your minds. Okay, yahi kar raha hu main. That's what I'm doing. So if I take the case of a DC motor, the working principle for a DC motor is nothing but very simple. Whenever there is an current carrying conductor in a magnetic field, it experiences a force. Correct? This is the law on which DC motors work. Whenever there is a current carrying conductor in a magnetic field, it experiences a force. This is the law on which it works. DC motor. And what is the working principle? The working principle is pretty simple. It states that electric energy converts into mechanical energy. That's what a DC motor do. DC motor converts electrical energy to mechanical energy. How? You are very sure about it. If you are not sure about it, just look at the fan above you, or just look at the fan wherever is in your house, or just look at the AC's motor wherever you have it. Correct? You can very clearly see that whenever you turn on the electric current passes through AC or fans, and then something starts rotating. The fan starts rotating. What is rotating it? The motor. The DC motor rotates it. Got a point? So what is happening? Electrical energy converting to mechanical energy. That is the working principle of a DC motor. The exact opposite happens in the case of generator. The exact opposite. what does it says? So what will the opposite? The opposite is nothing but here the AC generator converts mechanical energy into electrical energy. Same opposite. That's it. That is the working principle. An AC generator converts mechanical energy into electrical energy. That is the working principle in front of you, coming right for 1 to 2 marks, depending upon how easy paper CBSE is putting up. Okay? I hope all of you guys understood that. Got my point? Let's move on to construction now. I hope all of you guys understood working principle. I'll repeat it again. In the case of an AC generator converts mechanical energy into electrical energy. Moving on to the construction, very simple part. Construction तो बहुत simple है. Same parts as DC motor, not one thing which is different, I'll tell you that. But rest all the construction things are very exactly similar to DC motor. ठीक है? So if I just look here very carefully, guys, understand it very clearly, it's very important. I have two magnets. Okay? These are two magnets. Between providing the magnetic field, obviously, no, magnets are providing magnetic field, obviously, and between this magnets or between this magnetic field is kept the magical part for all of you called as the armature. Correct. Now this armature is made up of what? Copper. This armature is nothing but windings of copper coil. It's a copper coil produced in a length. Simple. Okay. Now the magical part. One end, what I mean is this particular wire, one end of the armature is connected to one of the split rings. Sorry, my mistake, slip rings, not split. Split is in motor. One of the end of the wire is connected to one of the slip rings, and the other end of the wire is connected to other of the second slip ring. There are two slip rings in the case of a generator, but for the DC motor there is a split ring. I hope you guys remember that. Now why is it called a slip ring? Because it is actually not attached to the circuit. Okay? It is not actually attached to the, what to say, the generator in such a way, it just keeps on rotating. तो कोई attachment नहीं है. Because if it was attached to something, it would not be able to rotate. No, imagine if this is rotating, if I attach it somewhere, it would not be able to rotate. So that's why it is called a slip ring, because it's rotating, it's free from everything, free from friction. ऐसे बोल रहा हूँ मैं, ठीक है? That's why it is called a slip ring. So I'll repeat it again. One end of the wire is connected to one of the slip ring, and the other end of the wire is connected to the second slip ring. So both of them are separated with each other, and one end of the coil connects the other end of the slip ring. Okay? Now, both the slip rings are attached to brushes. Both the slip rings, now if you are thinking कि slip rings इससे बने होते हैं, it's some kind of a metal or an alloy. It can be steel, it can be silver, iron, anything, does not matter. Copper also भी हो सकता है, tension लेने की जरूरत नहीं, simple है, ठीक है? Now, both the slip rings are connected to brushes. Now, these brushes are made up of carbon. Now, what do these brushes do? When this electric generator will be producing the current, the current will get produced in the armature coil. Somehow, I'll tell you that later, don't worry. Then it will come onto the slip ring, and this from the slip ring, it will be taken up by the brushes. It will be taken up by the brushes. Now, why are they called as brushes? If you don't remember, it's pretty simple. They are called as brushes because they look like brushes. They are like this. I hope all of you guys brush every day. Yeah, if you guys brush every day, you must understand this. This is how the brushes look like basically. Okay? So they look like brushes. So that's why they are there. Now you must be also thinking, sir, why do they look like brushes? Why can't they just take a rectangular piece? What is the requirement of the brush there? Why they can't just take a rectangular piece? Correct. It's because, guys, when we have a rectangular piece, the amount of electricity loss, the amount of electric energy being lost is more. Okay, it's completely more. It has been experimentally proven that way. When I use in form of brushes, the acceptance level or the electric energy being absorbed by the object is very high. It's very good. That's why they are in form of brushes. Understandable? Very good. Okay, clear. Now, why carbon? And it's a very important CBSE 10th question. Once it has come and no one was able to write it down. So please note it down. Why are carbon brushes used instead of any other metal? You could have used silver, you would have used copper, which are really good conductors. Why will you use carbon there? Now, carbon is being used there, guys, for one and only one important reason, that carbon has a very high melting point. Okay? And it can withstand a lot of temperature. Now, फिर again question आता है, sir, इसमें temperature कहाँ से आया? Where is the temperature coming from? It's very simple. Since the brushes are kind of linked to the slip ring, the slip ring will keep on rotating. Correct? The slip ring घूमता रहेगा, घूमता रहेगा, घूमता रहेगा, घूमता रहेगा. So somewhere or the other, it's actually creating a lot of friction there. So if I use a metal here, which cannot, and due to friction, what is generated? Temperature, heat is generated. So since it is rotating like this, very clearly, due to this friction, this particular brush is getting heated up. And also the slip ring is also getting heated up. This might damage the generator. This might damage the motor also. So that's the reason why we use carbon brushes, because carbon can withstand or it can modulate the temperature very easily. Okay, so that's why we take up carbon. So now you know the answer. This question is also asked in CBSE 12. So yaad rakhna. Okay. And now both these brushes are connected to an external circuit, which will tell us if current is being generated or not. This can be connected to a battery also, so that the current produced by the AC generator gets stored inside the battery, whatever it is. Okay. Or it can be also connected to a galvanometer to tell us whether the current is being produced or not. Simple. So guys, basically there are 4 to 5 parts of an AC generator, same to same as a DC motor. Let me repeat it. What are all they? Number 1, it is the magnets which produce the magnetic field. Number 2 is the armature coil, which actually contains the electric current which is being produced now. Okay. Now from this electric current, from this armature coil, the electric current passes to the slip rings. One end of the armature coil is connected to one of the slip ring, and the other coil is connected to the other slip ring. What does this slip ring do? Now this function of slip ring, I will keep it as a suspense because it is a very important thing. So I'll keep it as suspense right now. I'll tell you that later. But the slip rings are now attached with the brushes. Correct. Now they are attached to the brushes, and these brushes take up all the electric current produced by the armature coil and give it to the external circuit. External circuit can be a battery, it can be a house, it can be an electric lamp, it can be galvanometer, ammeter, whatever it you say. Okay, bus. This is the construction. And also in a way, I've told you the function of each and every part. Except this slip ring, I'll tell you that now. Right now I'll tell you. But the basic thing now we are going to understand कि काम कैसे होता है. Basic thing. ठीक है. Now this will bring us back to Mr. Michael Faraday. Michael Faraday told us very simply, if I move a magnet in the presence of a coil, the coil has an induced current. This was said by Michael Faraday, and this also actually came to be called as electromagnetic induction. So one guy, one of the most famous guys in the case of physics, I believe all of you guys knows his name. His name is Nikola Tesla. Correct? All of you guys must know his name. His name is Nikola Tesla. Correct? Very huge story about it. So I hope all of you guys know who is Nikola Tesla. Nikola Tesla didn't stop there. He went on to create this AC generator. He was the inventor of AC generator. What did he do? He thought, why don't we just use this electrical energy in our houses? So that's what he did. What he did, he placed a coil. Guys, I'm gonna repeat this again. This is the armature coil, and armature coil is made up of copper, and copper is a really good conductor. And this copper, now this conductor is now placed in between two magnets, between magnetic field. Now, if I ask you one very important question, are the magnets moving here? Think and tell me, are the magnets in the case of an AC generator moving? What do you think? I hope you guys would have understood it. No, it is not moving. It is stationary. Exactly correct. It is stationary. Cool. That's a very big problem, because magnets must move so that magnetic field can be generated. And magnetic field generated here, a changing magnetic field can only produce an induced current, not a stationary magnetic field, a changing one. So what do we do? It's pretty simple, guys. Just understand from this particular part here. If I have kept the magnet stationary and if I have moved the coil, instead of moving the magnet, if I have kept the magnet stationary and moved the coil, then also the magnetic field associated to the coil would change, no? You move the magnet or move the coil, the point is the same, correct? That's what Nikola Tesla did. Nikola Tesla thought about it and he did the same thing. He kept the magnetic field stationary, constant, and he rotated. He moved the armature coil, the conductor right there, due to which an induced current was generated. And then this induced current being generated went to the slip rings, and the slip rings gave the current to the brushes, and from the brushes it went on to the external circuit. Baat khatam. This is the working of an AC generator. Simple. So I'll just repeat this again. I have two magnets which is producing magnetic field. When the armature coil is being rotated, between the magnetic field and induced current is generated in the coil. This induced current is transferred to nothing else but the slip ring, and the slip ring takes up all the current produced by the coil, gives it to the brushes, and then the brushes accept it and give it to the external circuit. That's what it does. Okay. So if I make a flow chart, here very simply from the top for this particular electric generator, it will start from the armature coil giving electric current to slip ring. From slip ring it gives electric current to brushes, and brushes give electric current to what? The final thing, that is the external circuit. This is the chart, this is the flow. ठीक है? तो इतना ही है CBC 10th में. The CBC 10th only shows you this, only tells you this. But if you wanna go one more step deeper, it would be really amazing. Now what is that one more step deeper, one more step higher for 12th standard or for JEE level is very simple. Let me just put this one statement here. That statement is the current produced by this particular armature coil is alternating current. I'm like, what? How can a generator produce an alternating current, an AC current? And that's why this particular generator is called as AC generator. Like, what? How can that happen? And that is the next level which you're going to understand in this session itself. So let's focus. I hope all of you guys are interested to know how is this producing alternating current. Yeah, no. Let us understand this with the help of graphs also. It will be really crazy. Okay. So everyone, focus your energy here right now. I believe all of you guys understood how is it working basically. It's all electromagnetic induction, nothing else. But now let's understand hota kya hai. How is the current alternated? Simple. Okay. So guys, I hope all of you guys remember what is EMI, electromagnetic induction, what is Fleming's right hand rule, FRH. These two things are very important. Take care. So guys, this is the top view of AC generator. Two cases are there, case 1 and case 2. Forget case 2, focus on case 1 now. Completely focus on case 1 now. Understand it very clearly. बहुत simple सा है. Just understand very clearly. Magnet रखा हुआ है. You can see in front of you there are magnet, there is a coil. Imagine the coil is being rotated. As you can see very clearly, it's getting rotated this way. So what is that rotation? I think that's anti-clockwise, correct? So now the object is rotating anti-clockwise. Armature coil को मैंने नाम दे दिया. I am calling it A, B, C and D. I have given it name. ठीक है? So now when it is rotating anti-clockwise, my AB will go up, CD will go down. Correct? So AB goes up, CD goes down. ऐसा है? Clear है? Okay. And one more thing to notice, AB is connected to slip ring 1, CD is connected to slip ring 2. There is no connection between slip rings, both the slip rings, there is no connection between both the slip rings. There is no connection between one end of the coil to other slip ring. तो ऐसा कोई connection है नहीं. AB connected to slip ring 1, CD connected to slip ring 2. Slip ring 1 connected to B1, slip ring 2 connected to B2. ठीक है? तो और कोई extra connections नहीं है. ठीक है? Coming back to the point. The coil is like this. AB is going up, CD is coming down. Let us just focus on AB. For a moment, let us just focus on AB. Let's try to find out कि by using the Fleming's right hand rule, what is the direction of induced current when I rotate it. ठीक है? So now my object is rotating like this. So basically, the movement of AB is upward. So I'll project my thumb upward. I want all of you guys to do it with me. ठीक है? मेरे साथ करो इसको, बहुत मजा आएगा. So now the conductor is moving upward. This is the AB going upward. Okay. The direction of magnetic field is obviously from north to south. So if I make the direction of magnetic field, it always goes from north to south. So I think I need to shift it here now. So this is your movement of the conductor AB, and the forefinger will give you the direction of the magnetic field. Correct? So मैंने forefinger extend किया. As you can see, it is in the direction of the magnetic field very clearly. Now if I project my middle finger so that all the three are in 90 degrees perpendicular to each other, you can very clearly notice that induced current का direction अंदर की तरफ है. Correct? It's towards inside, and that's the direction of current which we have given here very correctly. So when AB is going up, direction of the current is towards A to B. Correct? The direction of the current is from A to B. Current direction. Let's now talk about CD. CD is going downward. So movement is downward. Correct? Movement is downward. Magnetic field का direction same है. Magnetic field direction is not changing. It's still going that way. Now if I project my middle finger out, you can notice the current is coming now outward. Correct? The current is coming outward, and that's how exactly we have represented here like this. Cool. So it states that now the current is flowing in this direction. That is ABCD is the current's direction. ABCD is the current's direction. Up AB went up, CD came down, and this happened. Okay. So AB rotated, it went up, and CD came down. Okay. Now what's happening? Now what's going to happen? Simply, just understand this. Okay. Now AB is going up, it came onto the right hand side, CD came here. Now as you can notice, CD is on here and AB is here. Now after CD reaches here, now CD will go up and AB will come. Correct? Obviously, ऐसे rotate होता है ना? It's still rotating anti-clockwise. So one time AB goes up, one time CD goes up, one time again AB goes up. Now since now CD is going up, magnetic field is in this direction. By applying Fleming's right hand rule, it's pretty obvious he will get the direction of the current upward. So now magically, CD's current direction was downward, but now it became upward. Damn. AB's current direction was upward, but now it became downward. So now in this particular arm, the current moves from D to C, and here it moves from B to A. So the current direction now it became DCBA. What you see right now? Current का value same है. The current magnitude, imagine 10 ampere is being produced, 10 ampere is the same current flowing through both the cases, but the direction changed. Direction of the current changed from this to this, that is from ABCD to DCBA. Direction of the current changed. Imagine what is going to happen in the external circuit. Just imagine this. Okay, guys, if I notice here very carefully, in the case of the first case, case 1, from AB the current went up to CD. So CD से current आ रहा है and it passed through B2, passed through the galvanometer, and from galvanometer it went to B1, and then it completed circuit by entering into AB. Correct? ये है direction. तो ऐसे जा रहा है current. If I do the same thing here I can notice from AB the current comes, enters the circuit through B1, passes through the galvanometer, passes through the resistor, enters B2, goes to CD, and then the circuit is complete. Correct? So the current direction has changed. Hence proved. Value same, current direction changed. Isn't that amazing? So this is how the current direction is changing, and what is changing it? Which particular device in this particular generator is changing the direction? That device is no one else but the slip rings. The slip rings are doing the magic here. Got my point? If you can notice very clearly, it's nothing else. It's the slip rings which is connecting the armature coil and the external circuit. That is the slip ring right there, which is actually doing the magic of changing the direction of current. And that's why slip rings in the case of AC generator, is called as a commutator. Very important word, very strong word which you need to know. It is called as a commutator. Now what is a commutator? Any device which changes the direction of current is called as a commutator, and in the case of DC motor it was the split ring. The split ring was the commutator there. Here it is the slip ring which is changing the direction of the current, because that is what is connecting the armature coil and the external circuit. If that was not there, nothing would have happened. Got my point? Now the best part about this is, still now you have not understood how is this AC, sir? Concentrate. Look at this. Oh, voltmeter is given. 1 second. Let me just change it to galvanometer. Look at this galvanometer in front of you. Okay. So you understood once the current goes from A, B, C, D, and once the current goes from DC, BA. One, the current goes from A, B, C, D and DC, BA. So current direction is changing. Correct. Current direction is changing from A, B, C, D. Now it's changing from DC, BA. That we proved. So in the case of a galvanometer, the galvanometer also must show me the change in the value. The change, it must show me the change. So just look at this galvanometer, it's showing the same thing. Okay, galvanometer, initially it was at 0. Then since the AB started going up, your galvanometer started going on the other side. And then AB came on this side. CD started going up. When CD started going up, your it came back to 0 and it went on to the other side. Okay, AB went up, so it is going to the maximum. Take it. Galvanometer is going to the maximum, then it's going to the minimum, raised here. Then CD going up, going on to the maximum on the other side, and then going again minimum. Got a point? So when my AB goes up, this is the reading. As you can see here very clearly, when one of the coil is going up, it is going up, and one of the coil is going down, it's going down. You can see the graph being created with the help of AC generator. Correct? तो इसका मैं ग्राफ बनाता हूँ simply बैठ के. I'll make the graph between current and time. Let me just make it. How does it look like? So as you can see, first of all the current increases. Okay, current is increasing. Then it comes back to 0. As you can see, current come back to 0. Then it goes on to the other side. So negative. So it goes negative. Then again comes back to 0. Guys, think and tell me, which is this graph for a DC current or for an AC current? Just think and tell me, DC or AC current? It's pretty obvious. As I can see, many of you guys are able to tell you that it's clearly the graph for AC current. Baat khatam. That's what all for today's master session, guys. Awesomely well done. I hope all of you guys enjoyed that part. One very important thing which I want to tell you, that is, now many of you guys might have a doubt here for any of the topics. Send me the doubts on the email which I told you already, that is k.abhishek@vedantu.com, or you can also send me the doubt in the comments below. Okay. Also let me know which other video you want me to take on which particular topic. I'll help you out, guys, by taking the video. Not a problem at all. Let me know how did this particular webinar master session went off. But one very important thing which I want to tell you guys is, basically I'll cover this difference between electric motor and electric generator after this particular thing which I want to tell you. It's very, very important. It's a very good thing for you. It's actually a surprise for all of you. That surprise is here, guys, very simple. As you guys know that the board exams are getting nearer and nearer. You might be having your pre-boards soon. So Vedantu has come up with a long-term course which is going to cover the entire syllabus for CBSE 10th for physics, chemistry, bio, maths, all these subjects. Okay. This is going to be a 1.5 hour course starting right from 8th October. It's 1.5 hours course per session, and it's going to be 10 sessions per week. 2 sessions for physics, 2 sessions for chemistry, 2 sessions for biology, and 4 sessions for maths. So 10 sessions per week, each session 1.5 hours, and we will complete the syllabus within February. Okay, within February. This will be a really quick revision for all of you guys. And for this, to purchase this particular, to get this particular course, you just need to go on to this particular website or web page link, www.vdnt.in fast track. Okay. Once you go into that, you will be seeing that the lightning deal is going on for 19,999. The actual price of the course, I don't know how much is that. We can check it out on the fast track. So if I take you to the course page, it will look like this. Okay, launching CBSE 10th, Maths and Science long-term course. The best part about this course will be, as you saw right now, we always go in depth. We always go higher level. So it is not only helpful for your CBSE 10th, it will be really helpful for your CBSE 12th and your JEE mains as well. Okay, for people, for all the students who are, right now itself preparing for it. And basically, one very important thing about this is key. Okay, I'll be personally handling physics. If you guys don't know, I personally handle 10th board examinations, and more than 500 students are actually being mentored under me, and they are all doing good. I believe all doing good, and many of you guys are my students here. I can see that very clearly. Okay, and maths will be taken by Mridul sir. Chemistry will be taken by Nazma ma'am, one of the best teachers in chemistry and maths, and also biology is again best teacher again. So as you guys know, it's taken by Dr. Divya ma'am. So great, all best teachers here. You don't worry about it at all. And one of the best things about Vedantu is it's completely planned out. So it's the entire syllabus coverage plus the test plus the revisions after each and every chapter. There are, as you can see, there are in total 6 subjective full syllabus tests and 20 subjective unit tests after every chapter, 30 chapter wise objective tests for all the subjects, and 30 chapter wise assignments for all the subjects, so that you can practice better and every time, so that you score amazingly well. Okay. And also, it's going to be a WhatsApp group created after you joining the course. And what will happen is you will be connected to the teachers 24/7. You can discuss with them, have any doubts until your examination is done, even after that. One of the best things again, that it's a live class. You're going to interact with me as you are able to do it now in the webinar, and all the classes are going to be recorded. Okay, so that whenever you want to watch it again, you can watch it again. You can download the notes of the teachers, notes of the session, everything you can do. So that's it. And as you guys saw already, that the lightning deal is going on, which is only for another 2 hours and 30 minutes, 40 minutes. 19,999 is the price, and that's the price right there. The actual price is 30,000 rupees, but for lightning deal, this is the price. And also one more thing which I want to tell all of you guys is key. It's a limited seat offer. We're not going to take much students. So if you guys want it, and join it completely. That's all about the course, guys. That's all about the course. Coming back to the concept here. So please note down the link here. It's www.vdnt.in/fast track. Okay, that's it. Cool. I believe all of you guys noted it. अब चलते हैं हमारे और खत्म करते हैं हमारे सेशन को आज. Difference between electric motor and electric generator, one of the simplest topics. I hope you guys have understood the differences already. First difference would be the construction itself. In the case of a DC motor, there are split rings. In the case of electric generator, it's slip rings. So prove construction difference. Number 2, what was that? Working principle, remember? Working principle for DC motor is converts electrical to mechanical energy. For AC generator, mechanical to electrical energy. Obviously, you know that. Correct. In that particular case, it works on the principle or the law that whenever a conductor is placed in a magnetic field, it experiences a force. Correct? And due to that force, it starts rotating and mechanical energy is being produced. But in the case of electric generator, it's the opposite. Here we give the mechanical energy and the armature starts rotating, due to which an induced current is being produced. Also, you can say it works on the law of electromagnetic induction. There the DC motor consumes electricity. Here the AC generator generates electricity. That's it, guys. I hope all of you guys enjoyed this session. And if you have any doubts related to this particular topic, please put down in the comments below. If there are any videos which you want me to take, any topics particularly which you want me to take to help you out, guys, I'm all out. You can let me know in the comments below. Let me know how do you like these sessions or this particular master session also in the comments below. Hit a like if you like it. Subscribe Vedantu's channel. Since the board exams are coming, you are going to benefit a lot from this channel. Okay, guys. So with that, I'll end the session for today. I believe all of you guys enjoyed it again. Have a nice evening. Have a nice night. Until the next session, guys. This is Abhishek signing off. Bye bye. Peace.